Good day everyone, my name is B.Tonga, best ECETA. In this video, we're going to perform the given task in our subject ECE 36. We're going to construct a code and then the schematic diagram and of course our breadboarding process, and then I am going to show you the resulting output of such task. Now, before I show you the code, this is the I'm sorry. This is the required task that I am given. The performance task number 6. The objective is to demonstrate the functionality of an LCD display using a microcontroller. The task is to create a video demonstration of your own program that will display the formatted text on your LCD screen. This is the program that I've constructed. Never find the criteria. This is the minimum electronic components that's required. Of course, the microcontroller, the Arduino R3, the breadboard, the power supply or battery. In my case, I am using my laptop, and the connecting wires. Of course, the LCD module, the 2x16 characters, and the 2-piece stack switch with a biasing resistor. I have a 10K pull-up biasing resistor. Okay, let's uh, let's see the guidelines here. The first guideline is to create a simple math or physics problem that involves calculation with at least three variables. That the given variables were represented by Greek letters, which you will need to create custom characters for this to be displayed properly in your LCD display. Now, I am going to post this in the link below, but this is the link for the customized for making customized characters. Now, this right here, okay. You are going to construct a customized character right here, like I will do in the up button. Okay. And you are going to copy this and paste it in your Arduino IDE. By the way, you will follow this configuration. The LCD, this is the pins that you should put the LCD in. The RS LCD should go to the 12, the 12 pin. The E is to the 11th. The D4 is the 5, and the D5 is the 4. Ironic, I know. And the D6 is the 3, and the D7 is the 2. Okay, let's go back to the guidelines. Number 2, add 2 tact switches and connect it to your microcontroller. These 2 tact switches shall be connected to pin number 8 and number 9, depending to you. And number 3, these 2 tact switches shall be programmed to be used to scroll down and scroll up in the text being displayed on your LCD screen. When the last line is displayed and the scroll down is pressed, the program must be able to go back and display the first line. However, if the first line is displayed and the scroll up is pressed, the program will not respond to this input. Okay, what this means is if the first line is displayed and you press the scroll up, it will do nothing at all. But if you are on the last line of your problem, you press the scroll down again, it will deliver you to the first line of your problem, which means it will go back and start the whole thing all over again. Number 4, the worded problem together with the complete solution must be able to be displayed on your LCD screen with the option to scroll up and scroll down, using the tact switches. Each line in the problem must have a maximum of 16 characters only because it is a 16 by 2 LCD screen. Show your name in the second line. See the sample problem below. There's a sample below there that I am going to show you that is created by, of course, by our professor. And as you can see, 16 characters only. Now this means that horizontally it is 16 characters maximum, starting with if you count it will start with the 0 to 1 to 2 to 3 up to 15. 0 to 15, which is 16 characters. Of course, vertically, it's 0 to 1, 2 characters. Number 5, create a demonstration video of your functioning program. Submit the link of your video uploaded in YouTube, as always. And we are going to submit here in the VLE, or Arduino IDE file, or the .ino file. This is the sample problem that our professor has given us. It is a problem with a minimum of 3 variables, represented each by Greek letters. Okay, formula, solving, and the final answer. Now that we are done with that, I'm sorry. Oh, okay. Now we're done with that. I am going to show you the program that I have constructed in the Arduino IDE. Of course, the first line is to include the liquid crystal.h, and we just followed this in the LCD custom character generator. Like here, we just followed it. As said earlier, the pins 8 and 9 should be used for the switches. So the pin 8 is used for the up. For me, I use it for the up switch. And the pin 9, I use it for the down switch. Of course, the boolean. And now we have the custom characters, the C, the Greek letter C. I don't know if I'm pronouncing it right, but C will represent the velocity factor. The gamma will represent the speed of light. The lambda wavelength, and of course the zeta will represent the actual length. Now this is the custom character pi, because in my formula I have 2 pi, so I made a custom character for it. And of course the up and down custom characters and the repeat custom characters. Now LCD begins 16 by 2. The number 5, the number 5, sorry, the number 5 will represent C, 6 gamma, 7 lambda, 8 zeta, 9 is the pi, 10 is up, 11 is down, and 12 is repeat. Okay, the bounds. We have in the void loop. As you can see, I have a page counter of 50 cases. Yes, right, I have 50 cases. I have that long of a problem. And here we are. Now, as always, I'm not going to take your time and explain each and every program here, each and every case, because trust me, it will take some time. 1 hour will not gonna be enough. As you can see, my professor only has a 22-line problem, and if you explain this, I can assure you 1 hour will be the minimum length of the video. If you explain each case, which right here is 22 cases, I guess. But for me, I have 50 cases. I made it so I have that long of a problem, because I know we skip the guidelines, but problem difficulty is part of the criteria. I mean criteria, yes, not guidelines, criteria. 40% problem difficulty is the criteria, so I made it a little difficult, just a little. Actually, it's a simple problem. I just increase it a little bit, so that I can at least have minimum grade for the problem difficulty. Okay, the case 1, of course, is the case 1. The case 2, case 3, you can see that. By the way, this program, I'm going to link the program, the Arduino IDE program right here, and my schematic diagram that I will show you later on in the description box down below, so you can check it out. Edit it if you want. You can make your own demonstration, and then customization, depending on you. Now case 4, I'm not going, as I said earlier, I'm not going to explain it because it will take a long time. Case 4, case 5. Now we will go to our solution. Where is it? Okay. I hope you understand me that I'm not really going to explain it um bit by bit. Now where is the solution? Now let EL equals to phase length, the F equals frequency. Now the let blank, as you can see it's blank, byte 5. Now that will be the Greek letter C, the customized character C, XI, which is equal to the velocity factor, as well as the gamma, the byte 6 for the speed of light, and the lambda for the wavelength, and of course the blank, the byte 8, zeta for the actual length. Now this is the formula. Okay, you can see it here, but you will see it later in the demonstration of the output. I'm sorry, excuse me. As you can see, it is very long for the formula because we're using customized characters, so we place them at using the set cursor. As you can see, set cursor 30, which means that horizontally it is in the third, no, fourth, because 0, 1, 2, 3 is in the fourth character, and 0 it is in the first layer vertically. Okay, I hope you understand that. This is the set cursor. The set cursor basically means that that is where you will put the characters or the text, or where will it start. Okay, case 37, 38, 39. This four lines here that you can see in each cases are the up and down characters. Now we will I'm going to slowly go to the last case, which is the case 50. As you can see, this right here, byte 10, byte 11 are the up and down characters, but this here is 10 and 12. Because in the guideline earlier, it says that when you reach the last line, when you press down again, the program must go back to the first line and start the thing all over again. I mean, not start the thing, start the problem or the text all over again. Now this byte 12 is a customized character that represents repeat. I know it doesn't look like that in the demonstration later, but that customized character will represent the repeat. Okay. Now, sorry, I'm just checking. Okay. Now we will go to our schematic diagram. Here we are. I know it's a bit messy. Of course, we have the two switches and our pull up resistor. I'm sorry, pull up resistors, which will be connected to the ground, and our first switch connected to 9, which our code means that it is a down switch, and this switch here connected to 8 is the up switch. Of course, the K, which has a 330 ohm resistor, the VD, which is have the 1K resistors, or if you can, since it's in series, it's a 3K resistor basically, and the RW as well as the VSS are connected also to the ground. Now A here and the VDD are connected to our 5-volt input pin, which basically means it's the one that will power the LCD module. Now the rest have a Arduino pin that it is destined to connect to. Well, destined. Now you just follow this one right here. The RS is in the 12, the A is in 11, the 4 is in the 5. the 5 is in the 4, the 6 is in the 3, and the 7 is in 2. I don't know if you can follow it because it's all jumbled up, but I just followed this configuration. Okay. Now that I've shown you the guidelines, my Arduino IDE code, which will be in the description box below, also the link of the LCD custom character generator, and also this right here, the schematic diagram, also on the link below. We are now going to my workstation, work on the breadboarding process, and of course, after the breadboarding process, I am going to show you the output product, or product, the same, the output of the task that is given to me. Now, without further ado, let's go! And welcome to my workstation. Here you will see the materials needed for the breadboarding process. This right here is the CH340G USB controller. Of course, the Arduino Uno R3 board. The 16x2 LCD screen right here. The Arduino connecting wires. Of course, these ones here are also connecting wires. The tack switches, the 10K resistors, the 1K resistors, and the 330 ohm resistor. Of course, the most important is the breadboard, because it's a breadboarding process. I hope you got the joke. Well, as you saw earlier, the code is already uploaded in here. All we need to do is assemble it in the breadboarding process, and I can show you the resulting product of the program here using this LCD screen. What we did there was a problem solving. We have a problem, and we have a solution that will solve the given problem. I hope you understand that. Now, we are going to start assembling the LCD side of the breadboarding process. Then we move on to the switch side, which is much easier because it's only a switch and a resistor. Okay, and without further ado, we are going to start the breadboarding process. Okay, we are done with the LCD part of our breadboarding process. Now we are going to start our switch side, the up and down switches. As you can see here with the 10K pull-up resistors. And without further ado, let's get a move on with that. there we have it. We are now mostly done with our breadboarding. All we have to do is connect this Arduino connecting wires, then connect it to our Arduino board, and I can show you the product. But first, you might wonder, why do I have to put this UTP cable wires here, right there? Well, the reason for that is these connections right here, especially the resistors, they have what you call a petite terminals. So if I don't put this here, they are very, what do you call this, loose. Yes, they are very loose in their connections. So I have put this connecting wires for them to have a snug fit to this hose. As you can see here, like just like this, it's very loose. So that's why I have to put these connecting wires. Now just gonna move on and connect this Arduino connecting wires to the board, and then to the Arduino board, and plug this with the CH340 driver. Plug this to my rock duct right there, as you can see the edge of it, and you can see the output of my program. Now let's start. There we go. We are now finished with the breadboarding process, as you can see. By the way, this will be our down button and our up button. As you saw in my code earlier, the down button is in the 8 pin and the up button is in the 9 pin. Maybe you can see it, but it's there. Okay, now I am going to show you the finished product of my task or my code. First, I'm gonna turn off all the lights. I mean, not all, but some lights and my flash. I've turned off my flash and my light. Now let's plug this in. Okay, now here is the finished product. I'm gonna read it to you. Okay. Problem solving by B.Tonga, me. Align with a phase length of 2.5 regions, carries a signal frequency of 350 megahertz and a velocity factor of 0.54. If you're wondering if this works, let me show you. Yep, it works. Where were we? 0.54. Find the wavelength and the actual length of the transmission line. Speed of light is given at 300 million meters per second, or 3 times 10 raised to 8 meters per second. Solution. Let EL is equals to phase length. Let F equals to frequency. Let this C, the Greek letter C, XI, equals velocity factor. Let gamma equals speed of light. Let lambda equals wavelength. And let zeta equals actual length. Formula. To get the wavelength, all we need to do is multiply the velocity factor to the speed of light, then divide the resulting product to the frequency. Now to get the actual length, you need to multiply the phase length to the lambda or the wavelength, then divide the product to 2 pi. Now here is the solving. As you can see, the velocity factor is 0.54 multiplied by the gamma, the speed of light, which is 3 times 10 raised to 8, divided by the frequency, which is 350 times 10 raised to 6, or 350 megahertz. It will result in the wavelength is equals to 0.462857. Moving on, the actual length zeta is equals to lambda wavelength multiplied by phase length, and then the product will be divided by 2 pi. As you can see, the lambda 0.462857 multiplied by 2.5 radians, which is the phase length, and then divided by 2 pi will result in 0.184165. Okay, final answer. The wavelength will be 0.463 meters or 46.3 centimeters, and the actual length will be 18.417 centimeters or 0.18417 meters. Now that the symbol right there means it's going to repeat if I press the down button again, and we'll go back to the first. But if I press the up button, it does nothing. But I can assure you the up button works. The arrows you see there is for the up and down options, and that's it. Thank you guys so much for watching this video. I hope you learned something today. Once again, I am B.Tonga, Best ECE3A. Hope you're having a good day, and goodbye.